All right. So, in order to do simplifying radicals, we have to take a step back and we have to talk about prime factorization, which you should have done somewhere in middle school, where you took the numbers and you broke them down into the tree factors, where it was like 60 broke into like 2 times 30, 30 broke into 5 times 6. That's what we're getting ready to do. You need to be able to do that in order to simplify radicals. So, we're going to do it the old school way, the way that you were taught, and then I'm going to teach you a new way how to do it. I don't care which way you choose. So I'm giving you the option. So we'll go old school, and then I'll show you the way that I do it. So old school, factor tree method. We're going to try to find the prime factorization of 120. So, Jesus? I mean... Okay, so prime factorization of 120. 120 breaks down into, Sienna said, 10 and 12. Okay, so now you need to look at it. Is 10 prime? Or does 10 break down even more? 10 breaks down even more. What does 10 break down into, Deja? 5 and... Huh?
She said it.
Did she? 5 and 2. Okay, so 10 breaks down into 5 and 2. Can 5 break down anymore?
No.
No. Can 2 break down anymore?
No.
No, we're done. Let's look at 12. 6 and 2. Fantastic. Does 6 break down even more? Yes, 2 and 3.
And we're done.
And we're finished. So your final answer then should be 2. Oops, let me bring this up a little bit more so you can see. 2 times 2 times 2. Notice I grouped all my 2's together. Times 3 times 5. You may also see this written as 2 to the 3rd, because I have 3 of them, times 3 times 5. Both of those mean the same exact thing. The 6 broke down. Remember, your finals are your final branches, so just these. Okay. This is why I don't like this method. Because then you start questioning yourself, should I have written that 6 down? Should I not have? Okay, so the other way that I do it is called the birthday cake method. So you've got 120, and you want to draw an L around it, a big L. It's like your layer of your cake. Okay, the only problem with this method is the numbers that you pull out have to be prime. Okay, so it has to be 2 or 3 or 5 or 7 or 11. Okay, you can't pull 12 and 10 like Sienna did with a factor tree because they're not prime. So what is the smallest prime number that divides into this?
2.
2. Good. It's an even number. As soon as you see even, the smallest prime is a 2. So we pull out a 2. When I divide 120 by 2, I'm left with what?
You had 2 dozen of 12 already. 2 times what? Yes.
60. Good. Okay. You draw another layer. What goes into 60 now?
3.
3. We can do a 3. That's prime. What happens when I divide 60 by 3? You get 20. You get a number. It's always his answer. It's some number.
It's either a big number or a little number.
Big number or a little number. What if it's a negative number? Well, I guess that would be a little number, right?
Yeah.
He said
small number.
Very small number, right. What goes into 20?
2.
2. And I'm left with 10. What goes into 10?
2.
And I'm left with a? What goes into 5?
Nothing.
1 or itself. Thank you. So we can pull out a 5 and we're left with 1.
Upside down?
When you get this 1 at the end, you know you're finished. So now all your factors are right along the side. 2, 3, 2, 2, and 5. So you're not searching all through the tree trying to find all of your factors.
I kind of like the cake.
You like the cake?
Yeah.
Again, the hardest part about the cake is some of you want to pull out that 10 and you can't with the cake. You have to pull out prime numbers. Okay. Questions? All right.
And if it ends in an even number, you automatically know the smallest is going to be a what?
2.
Go ahead.
Okay. Do you know how to tell whether a number is divisible by 3?
If you got a 6
If
or
you
9.
add the numbers
If you
together.
add all the digits together and that number is divisible by 3. So if I pick something like
3, 2, 1.
3.
321, what's 3 plus 2 plus 1?
6.
6.
The 6, 3,
Is divisible, is 6 divisible by 3?
No.
Yes.
So 321 is divisible by 3.
Do a 2-digit number.
Do a 2-digit number? 21.
Savage.
2 plus 1 is
3.
And 3 is divisible by 3.
3
That's
savage.
lame.
99.
That's lame.
81. 8 plus 1 is?
81.
9. And 9 is divisible by 3, so 81 is divisible by 3.
It
That's
works.
lame.
It works.
That's lame. He says that's lame.
Wait, what's what?
Okay.
I knew you was.
This glues in on page 75, ladies and gents. You can put it in sideways. You're not putting anything else on that page.
81.
Okay, so because some of you struggle so bad with prime numbers, I have provided you each a list of all of the prime numbers below 100. Okay, so you all should have this little sheet that says prime numbers below 100. You're going to glue this in at the top of page 76. Okay, this is going to be a reference thing. Make sure you glue it towards the top because you have one more thing that's going to glue in on it.
So do we have to cut it a little?
No,
No.
you can. You can trim it up if you are particular about it. That's fine. Okay. And then we're going to practice doing some prime factorization, and then I'm going to show you how to simplify radicals. And our lessons are done for today. Yay!
Not for real.
Can we talk spring vacation before summer? Like summer's a little too far away.
Yeah.
I mean, we got 51 more days.
That's it.
That's it. 51 school days. That doesn't count the weekends or Memorial Day.
I mean, you get a break on the weekends, though.
Yeah.
Holidays.
One school day. That's like.
But the weekends be going
Yeah.
off fast.
Technically, it should only be 50. I still have that extra day just in case the school board has decided we're going to make that Monday up.
I'm hoping that they.
Oh, let me
I'm hoping that they. I mean, we have enough instructional hours.
Right.
That's the purpose.
All right. We're going to do this sheet that says prime factorization. We're going to do all the work first, and then I'm going to show you how to cut and fold it. Okay, we're going to be making a bunch of these little tiny books
Today?
throughout this unit.
I thought
Okay.
it was today.
Not today.
That's a song.
Oh, yeah.
Not today. Not today. It's gotta get easier. It's from
Okay. So do me a favor and find the piece that says find the prime factorization of 48. That's where we're going to start. So if you prefer the factor tree method, by all means, do it. I'm going to stick with the birthday cake. Okay. Because Christian likes it. Right. Huh? Yeah. You can flip back and forth. Okay. So find the prime factorization of 48. What's the smallest prime number that goes into 48? 2. It's even.
Oh my God.
When I divide 48 by 2, I'm left with 24.
24.
What goes into 24?
2.
And that leaves me with 12. What goes into 12?
2.
And that leaves me with 6.
2.
2.
2.
That leaves me with,
3.
and finally, 3. And it leaves me with 1. Okay. You're fine.
That's supposed to be the candle.
Huh? Yeah, that's supposed to be your candle.
No. Where's the cake?
Huh?
Where's the cake?
These are your layers of your cake. It's an upside down. If I flip it over,
What?
that's supposed to be like layers of a cake.
It look like a
Birthday
SpongeBob
cake.
blade.
that I need in my life.
Okay. So we can either write this as 2 times 2 times 2 times 2 times 3, or this can also be written as 2 to the 4th times 3. Okay, you've got 4 2s and a 3.
4 2 and a 3.
4 2s and a 3. Okay? Slide it over. The next one. Prime factorization of 38. 2.
30 of these ones is 2.
19.
19. What goes into 19?
8. I mean, no, not 8.
Nothing.
Nothing.
Nothing. 19 is prime. So 19 comes out and you're left with a 1.
Oh.
So your prime factorization is just 2 times 19.
Oh my God.
We have a small cake.
Teeny tiny cake.
It's a birthday cake.
Okay.
Big ones.
All right.
Yeah, y'all gay as fuck. I mean, y'all get it.
Find the prime factorization of 88. 2 first. And that breaks me down to 44.
Oh, shoot.
We can do 2 again.
I'm tired of 2.
22.
Oh my God. 22 cents.
2 and 11. What goes into 11? Nothing, just 11. So your final prime factorization is 2 times 3, or I'm sorry, yeah, 2 times 3. 2 to the 3rd times 11.
This is fun.
Is it fun? Okay.
Work is not fun.
102.
Let's get paid.
We start with 2. 51.
What's that? 5.
This isn't radio anymore.
It is not divisible by 5. Remember, if it's divisible by 5, it has to be 5 or a 0 at the end.
2 again.
It's not even.
3.
Why is it 3?
5 and 1.
5 plus 1 is 6, and 6 is divisible by 3, which means this is divisible by 3. What do you get, though, when you divide 51 by 3? 17.
Next album.
And that's it.
That's it. 17 is prime. So your final is 2 times 3 times 17.
$147 on the dot.
Okay. 147.
Sam.
3. Okay. Caleb said 3. Think about it. 7 plus 4 plus 1 is 12, which means this is divisible by 3.
Good job.
I thought this either gonna be 2 or 3.
Bro.
What do I get when I divide 147 by 3? 49.
7.
7, and I'm left with 7. Good.
That's it.
And 7. So my final answer then is 3 times 7 to the second power, because I have 2 7s there. And we've got one more. 65.
5.
Good. Anytime it ends in a 0 and a 5, you should probably start off with 5. That gives you what?
13.
13.
That's from.
And that's prime. So we are done. So 5 times 13.
I say get her done.
Okay. I need you to please pay attention to how we fold this. If you fold it wrong, you will ruin it. So, first things first, fold it like a hot dog. Let me zoom out so you can see what I'm doing. Fold it hot dog style. Bless you, my dear.
Hot dog from side.
Okay. Once you're done, you're going to open it back up. Okay. So fold it hot dog style, open it back up. Then I want you to fold it hamburger style. So fold it hot dog, open it up, fold it hamburger. Now we're talking about food and I'm getting hungry.
You or me?
You didn't make it here for breakfast?
Nope.
Or you just didn't want breakfast?
Breakfast is good.
Okay.
Everything in school produces is nasty.
You are not opening this back up. Leave it hamburger style and fold it in half again. Skinny hamburger.
What?
I'm going skinny hamburger. So you fold hamburger and then fold it again.
Like this?
Yes. Like that.
This, you fold hamburger and make it a skinny hamburger.
Oh, that question. Yeah, but you're right. It's
Oh,
cool.
yeah, I guess that's hot dog style now. After it became hamburger. Okay, you good?
When do we get free pizza again? April.
Okay. So now you're going to open this whole thing up. Oh, I lied. Leave it hamburger style. What you need to do, look, this is where it's creased. This is the part that is open. Okay. Against the part that's creased, you want to make a cut to this line where you fold it. Okay. So go by the side that's creased.
This side?
Yes. Okay. The side where it says practicing prime factorization will be the side that you're going to cut. If you're questioning
Yes,
it,
right.
please let me look at it before you cut it. Yes. Cut up to that
You
fold
did
that
it
you
wrong.
just made.
Okay, look. That's for your smartness.
Good.
What's up?
Yellow for like.
Got it.
I'm so happy for some soup.
Hey, one.
I know. Huh? Oh, I already know.
Okay, does everybody have their cut in? Once you have your cut in, open the whole thing back up.
Open the whole thing back.
Okay, you're gonna take your edges and see how this is like opening up to like a mouth or something.
Yeah.
Okay, you're gonna pinch it together. You're gonna pinch it together, okay, to make this diamond looking shape and close it. And it will fold up into a little book. Okay,
Oh my God, Christian.
you're fine. Open it up.
Oh, I mean. Oh, like that. Yeah.
Pinch.
Oh, you gonna do it?
What is title at?
You're fine. Pinch
Got
and
it.
fold. Pinch and fold. Stuck?
I got slowly doing something, learning something. Thank you, all right.
The diamond.
You didn't even do it right.
Did you? Okay, there you go. Fantastic. And then fold it up.
Mine is a.
Anybody else need help with their little book? Elijah.
It's cold.
I know.
It's cool.
Hey, I hope for it.
He said iPhone 4.
All right.
Where you look 12? 6 and up.
Why? Why not 4?
I got a 6. See?
I got a.
Okay. This booklet's gonna glue in underneath where you put the prime factors under 100.
Oh my God.
Okay, so this glues in at the bottom of 76. So page 76 is gonna look something like this.
This is a story. Will Smith is my daddy. Just mad I wasn't trying.
Yeah, that's fine. Since there's nothing written there anyway. Okay. When you guys are done gluing that in, we're gonna jump here. We need to talk about the parts of a radical, and then I'm gonna go ahead and show you how to simplify.
Oh my God.
We got 6 more examples.
I thought you were about to say 6 more minutes.
6 more examples.
6
We
more.
still got about 20 minutes of class.
6 more. 6 more.
Oh, damn, I forgot we had
The delay? I know it screws me up every time because I'm thinking 40. Wait, class should have been over.
So how long are
Wait, you glue in on that.
Is our
The
book-
little book glues in right underneath where you glued the 100, the prime factors under 100.
Is our 4th period gonna be long?
No. An hour and 5
Well,
minutes.
Oh man, yes.
So your longest class will always be third block because they've got to fit the
I
lunch.
hate third.
Oh, like my
Right.
period.
I don't
Yeah.
think 4th be going by.
Strongly dislike.
Right.
Strongly dislike.
I hate
And it's
All right,
I strongly-
So- we're going to strongly start to love it.
I love
Shoot.
it.
Shut up, the door. Closer to the bathroom.
Huh?
On the bathroom side. Someone know who it is. Huh? Okay, I ain't say all that.
Okay.
I was watching Winston.
So- We already talked about what was this little number called? The what? The index. Okay. This is your index. Your index tells you what route you're trying to take. Okay. Your index tells you what route you're trying to take. Notice there's a little asterisk here that goes down to here. If the index is not written, then it's automatically a 2. Okay? Square root. If they don't write it, it's automatically a 2. What your index does is it tells you which we're grouping numbers in. Okay? It'll make sense in a little bit. Okay. This symbol right here that this is pointing to, this is called your radical symbol. Anything that falls underneath that symbol, whether it be a number or a variable or a mixture of both, is called your radicand. Yes. Okay. That's anything that falls underneath of that symbol. Okay. Remember too, if you had something like 2x, that meant 2 times your number, which means 2 was your coefficient. Okay? With radicals, we also have a coefficient. So you may see something like 2 square roots of 3. That means 2 times the square root of 3. Just like 2x meant 2 times x. And then right at the bottom of this, I give you all the steps to simplifying radicals. So step 1 said find the prime factorization of the radicand. That's what we just got done practicing. Okay. Then you're going to look at the index and it tells you what size of the identical groups. We're going to circle them. For each circle group, we're going to pull it out front. And the radical symbol will disappear if everything is gone. Okay. So these are just your steps to keep in your notebook for reference. This glues in on page 77. And we're going to finish with this paper that you're just going to fold in half.
How do they make one?
Christian, have you ever watched the show called How It's Made?
No. Oh yeah.
You need to watch that show.
I still won't.
I don't know if they're airing anything new, but it might be on one of those like random like 140 some channel. You might even be able to look it up on like YouTube or something. Really good show.
Wait, how is it made?
It's called How It's Made. I've watched them make like balloons and crayons, and it's really cool.
Oh, I know how to make crayons. How do they make balloons?
Okay.
That's really cool.
Okay. This page just gets folded in half. We've got 6 examples and we're finished, my friends. Okay. So step number 1, when you're simplifying radicals, I want you to take the number that is underneath your radicand and find the prime factorization of it. So we need to take 28 and we need to find the prime factorization. What goes in to 28? 2. When I divide by 2, I'm left with 14. What goes into 14? What goes into 7? And we're left with? Okay. Now, when we did the prime factorization, I taught you how to do 2 to the second power. Skip that for now. I want you to write it out just like you see it. So 28 breaks down into 2 times 2 times 7. Okay. Okay. Now, look at your variables. If I have x to the third, how many x's do I have? Times x. We also have a y and 8 z's. If you need to step down and do your z's below it, that's fine. 1, 2, 3, 4, 5, 6, 7, 8. I have to put my line in between my z's because sometimes when I write my 2 and I don't have the loop, they look like 2's. Okay. Once you do that, that's your prime factorization. Now, tell me, what is my index in this problem? 2. There's nothing written there, so my index is 2. So that tells me I need to go down to my prime factorization and group my stuff in 2's. So I've got 2 2's, so I can circle them. I don't have anything that matches with a 7, so we're going to move on. I've got 2 x's. Technically, I have 3, but I can only group in 2's. So that third one stays to the side. There's only 1 y, so we have to skip it. My z's, I've got a group of 2 here, another group of 2, another one. I've got 4 groups of 2's. We have one last step and we're finished. For real? Okay, so this is a 2. I circled 2's. So I pull a 2 out front. How many times did I circle 2's? Once. So leave it alone. I also circled an X. How many times did I circle them? 1. I also circled a Z. How many times did I circle them? 4. So this is Z to the 4th.
Oh, that's our answer.
Okay. I circled 4 Z's, 4 groups of Z's. So that's Z to the 4th. Okay. Now, I had stuff that I didn't circle. So you put your square root back down. And everything you didn't circle goes back underneath the square root. And that's your answer.
Oh, Michael answer.
That was like magic right there. For real. I'm not even lying.
That's extra magic that I don't really want to do. Right. Statement facts.
Statement facts. Okay. So let's jump down to this one. We got to break down 32. 2 and 16. 2 and 8. 2 and 4. 2 and 2. 2 and 1. So I can rewrite 32 as 2 times 2 times 2 times 2 times 2. I then have 2 A's and 6 B's. Two A's because I've got A squared and 6 B's because I have B to the 6th power. Okay. What is my index this time? Okay.
3.
My index is a 3. So now instead of circling in 2's, I'm going to circle in 3's. So I've got 3 2's that I can circle. I only have 2 left, so I can't circle anymore. I only have 2 A's. Can't circle those. I need 3. But I can circle a group of B's and another group of B's.
Big ball of brain.
Okay. So I pull out, I have one group of 2s, so that's just a 2. Because I only have one group of them. I circled B's, and I circled 2 groups of them, so that's B squared. Now you've got your cubed root. Don't forget that index. Okay, before you plug this back in here, what's 2 times 2?
4.
This is 4. What's A times A? A squared. So underneath your cubed root is 4A squared.
Oh my man.
Oh my Lanta.
Oh my God. Jesus.
I've been rewatching Fuller House, and DJ says that all the time. Oh my Lanta. I need you to get Netflix and watch some Fuller
I be
House.
seeing the
Oh.
You've never watched even Full House growing up?
I watched Full House growing up.
You need to go watch Fuller House. Now DJ has 3 kids and she owns the house, and Kimmy and Stephanie live with her.
That's too much.
Every time they connect, come on, I always switch over to adult.
Okay,
Rick and Morty.
guys,
Right.
unfortunately we're running out of time, so this is going to be the last example that I'm going to be able to finish with you. Okay, so let's run through this one real fast. 20 breaks down into 2 and 10. What goes into 10? 2 and 5, 5 and 1. So 2 times 2 times 5. Holy cow. Then we've got 10 X's. 1, 2, 7, 8, 9, 10. And 5 Y's.
Yeah, we got a circle 4.
Okay. Christian has already said my index is 4. So I don't have enough 2s.
Nope.
I don't have enough 5s. But I've got enough X's for 2 groups. And I have enough Y's for 1 group. Bless you. So this becomes X, and I circled 2 groups. So that's X squared. I then circled a Y, only 1 group, so it's just Y. So then we throw down our radical, the 4th root. Okay, we got to put everything back together. What's 2 times 2 times 5?
20.
20. So 20 goes back under the square root. What's X times X?
X squared.
X squared. And then we have a Y. And you're done. Boom. Okay.
You wanted to do these?